Imagine this Earth, our home, a planet teeming with life and countless species, was once a ball of boiling lava, devoid of life, over 4 billion years ago. But how did this fiery sphere transform into the life-supporting world we inhabit today? Where did the water come from? How was the moon formed? These answers lie in the origins of our sun and solar system. The beginning, a cloud of gas and dust 4.6 billion years ago, our solar system did not exist. Instead, there was a vast, cold, and dark expanse of space. Floating within this void was a massive cloud of gas and dust, now known as the solar nebula. This cloud was primarily made up of hydrogen and helium. For millions of years, it drifted peacefully through the cosmos. Then, a dramatic event disrupted its serenity, a supernova, the explosion of a dying star nearby. The shockwaves from the supernova triggered instability within the nebula. Gravity pulled gas and dust into clumps, causing the cloud to collapse inward. As it did, the material began to rotate, forming a flat, spinning disk called the protoplanetary disk. At the center of this disk, pressure and temperature built up until nuclear fusion ignited, giving birth to our Sun. The Sun claims 99.8% of the nebula's mass, leaving just 0.2% for everything else: planets, moons, asteroids, and comets. From dust to planets in the outer regions of the protoplanetary disk, tiny particles of dust began sticking together through static forces and chemical bonding. Over millions of years, these clusters grew larger, forming kilometer-sized objects called planetesimals. As these collided, gravity caused them to combine into larger bodies, called protoplanets. One of these protoplanets would eventually become Earth. But in its early days, Earth was far from the blue and green planet we know. It was a seething mass of molten rock, undergoing constant collisions with other planetesimals. These violent impacts generated immense heat, melting rocks and creating vast oceans of lava. The Hadean Eon, Earth's fiery beginnings. This chaotic period, from 4.6 to 4 billion years ago, is known as the Hadean Eon, named after Hades, the Greek god of the underworld. The Earth's surface was a hellish landscape of molten rock, volcanic eruptions, and relentless asteroid impacts. Surprisingly, this infernal period was crucial for Earth's transformation. Many of the colliding asteroids and comets contained water in the form of ice. When they struck Earth, their water vaporized, rose into the atmosphere, and eventually fell as rain. Over time, these repeated impacts and rains contributed to the accumulation of water, laying the groundwork for oceans. By the end of the Hadean Eon, Earth had cooled enough for its surface to solidify into a homogeneous layer of lava, creating the foundation for the planet's geological structure. Differentiation, the formation of Earth's layers as Earth cooled, a process called differentiation occurred. Heavy elements like iron and nickel sank toward the center, forming the core, while lighter elements like silicon and oxygen rose to the surface, creating the crust. Between these layers lay the mantle, a thick, semi-solid layer of rock. The Earth's core, composed of iron and nickel, remains incredibly hot, around 6,000 degrees Celsius. Despite this, the inner core is solid due to the immense pressure at Earth's center, while the outer core remains liquid. The churning liquid in the outer core generates Earth's magnetic field, which protects us from harmful solar radiation and helps sustain life by holding the atmosphere in place. The Moon's origin, a cosmic collision. How did Earth acquire its moon? Scientists believe the answer lies in a massive collision during the Hadean Eon. A Mars-sized protoplanet, named Theia, collided with Earth around 4.5 billion years ago. The impact was catastrophic, melting both bodies and ejecting a significant amount of debris into space. This debris eventually coalesced to form the Moon. Evidence supporting this theory includes the similarities in the chemical composition of rocks on Earth and the Moon, as confirmed by samples brought back by NASA's Apollo missions. The Moon plays a vital role in Earth's stability. Its gravitational pull creates tides, which helped early organisms transition from water to land. Additionally, the collision tilted Earth's axis by 23.5 degrees, giving us the seasons and a relatively stable climate, essential conditions for life. The Archean Eon, Earth takes shape from 4 to 2.5 billion years ago. During the Archean Eon, Earth began to stabilize. The crust thickened, and volcanic activity released gases like water vapor, carbon dioxide, and methane, forming Earth's early atmosphere. Initially, this atmosphere lacked oxygen and was toxic to life as we know it. As the planet cooled further, water vapor condensed and fell as rain, filling basins to form primitive oceans. These oceans, along with volcanic activity, created the conditions necessary for life to begin. Layers within layers. Today, we know Earth has three primary layers: the crust, mantle, and core. However, these can be further divided based on their physical properties. The lithosphere, the rigid outer shell, floats on the more fluid asthenosphere. Beneath these lies the lower mantle, and finally, the outer and inner cores. The lithosphere is broken into tectonic plates, which move and interact at their boundaries, causing earthquakes, volcanic eruptions, and the creation of mountains. A journey from chaos to life, from a swirling cloud of gas and dust to a molten ball of lava, and finally to a life-sustaining planet. Earth's transformation is a story of cosmic collisions, immense heat, and gradual cooling. Each stage of this journey, from the formation of the Sun to the creation of oceans and the Moon, was essential in shaping the planet we call home. Understanding Earth's history not only reveals our planet's incredible resilience but also highlights the delicate balance that makes life possible. As we continue to explore our origins, we gain a deeper appreciation for the unique place Earth holds in the cosmos.